Hi, I'm going to take you through some simple univariate analysis using Excel. So let's get started. So what we're going to do is analyze one variable or one feature, which is the definition of a univariate analysis. We're going to analyze the height of participants for the purpose of furniture and interior design specification. We're going to create a report, visuals to demonstrate our analysis. Here's what we're going to try to achieve. Here are the steps. We're going to look at the central tendency and variance. We're going to look at the distribution, the probability, sampling, and visualize. Of course, there are a lot more things you can do with univariate analysis, but for this simple walkthrough, we're going to achieve this. So here is our output. We've created a visual format where we can see an analysis being conducted on height. One thing we were able to achieve is categorize the height. Even though we're just looking at height, we can put it in two categories and it still follows the univariate analysis. We created a summary, and I'm going to walk you through each one of these steps. There's a clear difference in the maximum female and male height, where the average height of female is approximately 6 inches lower than the male height of 69 inches. The data follows a normal distribution, which we see in our histograms. We'll walk through how to create these very quickly. Because it follows a normal distribution, we know that all the data falls within the majority of the data falls within 3 standard deviations, and we've calculated some of these key metrics over here with standard deviation, and there's a slight difference between male and female. We also performed a t-test, which reveals there is a significant difference in sample means with a p-value of less than 5. Here we have our ECDF plots, which is empirical cumulative distribution plots, where we can see the probability of where our data is. So we can see for males, if I put it at the 99% mark, we can see 99% of our data is under the 75 inches mark. And if I go to 99 here, we can see that 99% of all the female height is below 70 inches. Finally, we can see the range of our data using box and whisker plots. We can see the outliers here. We've calculated the range here for our box and whisker plots. And we can see that the female mean and median is a lot lower than the males. So let's get started on how to quickly create this. So our data doesn't come in this side-to-side format. It comes in a raw format. And we can see here we have 10,000 participants. And then we have the male and gender column. This is just the average and the median. So we can see that very similar, which falls in a normal distribution. So the first thing I need to do is get the male and female categories next to each other because it's much easier. All you do is copy and paste this over, and we end up so I've already done a little bit of work by putting the metrics next to each other because this will allow us to do it very quickly. We want to get the mean, the mode, and the median. Okay, so all we have to do, because they're next to each other, we want to use the average function, and then we can highlight and control shift and down to get that whole column, and then we can get the male and average height. And now that we have that next to each other, we can just drag it over. Let's ensure that we only have 2 decimal points. So we're going to pull this over. So we can see there's a difference in mean. Let's get the mode. Now there's a couple different modes. However, I'm just going to use the legacy. We can see the modes are very similar to the means in each category. And let's get the median. So now that we have that descriptive statistics, we know that for the male, the mean, the mode, and median are almost similar. Same with the female. We can infer that this is a normal distribution, a bell curve. So we can quickly create a histogram to see how our data is shaped, follows the descriptions of a bell curve where the mean, the mode, and the median are very similar. So we know this is the male chart. And let's get female. We can see that those are so similar. And let's just change the color here to orange. We see these are very similar, but we can already see that there is a little bit of a difference. So next we want to start getting our quartiles. Our quartiles, when we break the data up into quarters. So quartile 3 is, we're going to use the quartile and we're going to use the legacy function. Oops, and I forgot to write 3. So we add quartile 3 there, and we're going to specify quartile 3. We can just drag that over. We do the same for our quartile 1. We're going to pull that over. So this is our low 25% of the data. So if we're looking at males, we can see that is going to be around this area. But obviously we can visualize this better using box plots. But the IQR is the difference between these two numbers. So let's quickly calculate that. Pull that over. So we can see this is our IQR for male and female. Now that we have that, let's create a box plot so we can understand our upper outlier range and our lower outlier range. So if I highlight the male column, I go to Insert, and I use a box and whisker plot. It's not the prettiest, so what we can do, we can highlight the axis, right click, Format Axis, and maybe we set the minimum to 50. And we can probably go to 55 for that one, so we can have a nice box plot. All right, we can do the same for the female. Format the axis, and that might be too much, so let's do 50 because we might be missing some points. We can, of course, change the color. And now we can see where our data lies. And maybe we can fix that a little bit. And so here's our box and whisker plot. This X is the mean, and the median is the line. And now we can calculate the edges of our data using the upper outlier range. And all that is a simple formula where we take the upper bound, which is Q3. Then we're going to calculate the upper limit of our data by taking the third quartile, which is our top percentage, top 25%, adding 1.5 times our IQR. And we're going to pull that over. And then for our lower range, we're going to get our Q1. So equals Q1 minus 1.5 times our IQR. And we pull that over. Okay, so now that we have that, we can see the ends of our data. So we can see that limit for male is 76.71, and we can see that we calculated that here. Of course, we can also get all of this on one by just highlighting it inserting, going over to this. So we can always put them on the same axis, and this is just a better way to see it. So I'm going to quickly get rid of these, and then I am going to change our axis. So now we can see that a little bit better. And the things that are outside, the points that are outside our area here, are our outliers. Now that we have looked at our distribution, we looked at the range of our data. Now let's look at probability. Harder to do, a few more steps. So what we're going to do, so I'm going to go over here, I'm going to paste, I'm going to separate these because I need to do some calculation. And this is going to be represented by our ECDF functions. So you can see where the data falls, and we can see the full set of it. So I'm going to go back over to our, okay, so what we want to do at this stage is we want to calculate the probability, because we need to sort all of this data first so it flows like this. So to create a empirical cumulative distribution plot, we need to ensure that our data is sorted. So if I go back over, I'm going to sort my data by going to the Home tab, going to Data, hitting Sort, and we continue with that selection. All right, and we're going to do the same for female. We're going to sort that data, continue with the current selection, female height, sort. Now that we have that, we can start by adding our count, and we're going to turn this count into a probability. So now that we have that, and so we have 10,002 participants equally split between male and female. So I know that there are 5,001, and you can quickly check that by pressing Control Shift and I, and you can see that the last column, the last row is 5,001. So I'm going to go back up. What I'm going to do is divide each one of these by 5,000, and we're going to get a percentage. So I'm going to divide this by 5,001. I'll lock that, and then hit this so we can see that grow all the way to almost 1. 5,001. Lock that with F4. We hit that so it goes all the way down. Now that we have our data, we can create a cumulative distribution plot. I'm going to go to Insert, and this time I'm highlighting our value, which is male height in inches, and the probability. I'm going over to the Insert, so I can insert a graph, and I'm going to go to our scatter plot, and I'm going to choose the line. And now you already see that we have the makings of our distribution. We want to, of course, format the axis by highlighting, going to Format Axis, and we can see that the majority of this starts around 50. So we can even do 55 to make that look a little better. And just to save time, I'm going to show you what that looks like. So now we can turn this into a percentage. And we can see that, okay, at this point, 13% of our data is under 66 inches. If I go here, we can see that 93% of our data is under 73 inches. If I go to something I've already made, Let's go back over to the dashboard and see what we have left. So now that we have this dashboard that we created, or visual, not necessarily a dashboard because it's not interactive, we can see that we created a standard deviation also. We're just using the standard deviation P because we're using the full population. And we can see that the standard deviation is 2.86 and 2.71. And we know that, within 3 standard deviations, that all our data falls within this normal distribution plot. 3 standard deviations from the mean. So also we have this where we ran a t-test, where we looked at these 2 categories to see if the mean was actually different. Of course, we can see the mean here. There is a difference, but sometimes you want a statistical difference. And the way to do that is through a t-test. We can actually just use this section here, but this is 5,000 different participants, 5,000 for male and 5,000 for female. So I'm going to show you how to just sample this so we can look at maybe 30 samples, which is where you would use a t-test. If it was more than 30 samples, you might use a z-test. So how do we sample? Let's go and copy our data. So what we can do, we can copy our data. Copy. Let's create a new page and paste. I'm going to take this and just move it over by highlighting it. And now I'm going to create a random number. So I'm just going to call this rand. Then I'm going to put the random function here. Close the function. And that's going to give us a random number. I am just going to click that and run that down. Now, if every time you press enter or you do something in Excel, it's going to change. For example, if I put random here, it'll initiate, but you can see it also changes here. So what we need to do is copy and paste so it doesn't continually change. So I'm going to drag that down and you can see it already changed again. So I'm going to copy and paste. And the way you copy and paste just the values is through the 1, 2, 3 icon here, and you can see it says values. Now that we have this, we can randomize our data by sorting. So I'm going to go over and I'm going to highlight both of these rows. Just highlight the rand, home, go to data, go to sort. I want to expand, so I include the whole column. I want to sort by rand. And you can see now this data is randomly sorted so we can get a random sample. I'm going to do the same here, data, sort, expand, so we can get this column. We want to sort by rand. Now we have a random sample. We're going to sample 30 of these, or around 30, and we're going to use a t-test. So equals t.test. And what we're going to do is get the first array. So let's go down to, let's do like 27 of these. So A2 to A29. And then I'm going to do the same here. Now, the one thing with a t-test, we know we have a distribution. We have a normal distribution. And our normal distribution has 2 tails, and most distributions going to have a tail. It may be skewed. Ours is a 2-tail test because we just want to know if it's different. We don't care if it's higher or lower. So I'm going to choose 2-tail distribution. Then the next thing I'm going to choose, is it paired or do we have two equal variances, which is homoscedasticity? So we have very similar variances, as you see from our data, from our metrics table, that everything is pretty simple and similar. So we're going to choose 2. Now for significance, usually we use a p-value of 0.05. And so our test statistics needs to fall under that number. So you can see that it's a very small number. If you wanted to see what that is, we would call that a number. And you can see it's so small it goes to 0. But I would have to pull it out. And you can see that we have our 4 here. So it's definitely significant difference between these two means. So what we've done is be able to create the summary. We have a standard deviation that we created just using the standard deviation function. And range is just the max minus the min. And we can see that the ranges are different. That's just a quick and easy walkthrough on how to do univariate analysis. I hope that helps. Please like and subscribe if you got some value out of this.